Thank you, everyone. Let me get started. So my product and company is K Medical, and what I'm developing is a smart mattress that prevents pressure injury. So this is a widespread problem for immobile patients who cannot move, and they get painful bed sores. And within 3 to 4 hours, they can develop sores on the back, buttocks, heels. There are 2.5 million patients affected every year, and 60,000 of these die as a direct result of these pressure sores or pressure ulcers. This is one of the most litigated cases at the nursing homes because it's easy to say that lack of care caused these bed sores, and then settlements range in millions, from thousands to millions of dollars. And 87% of these lawsuits favor the patients and their families. So it's a big thing for the nursing homes to not get into these lawsuits. Patients have to be turned around every 2 hours, and nurses have a hard time turning the patients. It also bothers the patients. Their skin gets macerated, and their sleeps are disturbed. The patient's sleep is disturbed. So what we have is a smart mattress that prevents pressure injury. It changes pressure points every 20 minutes, and it prevents the nurses from heavy lifting and provides comfort by continuous pressure monitoring. And it also logs the alternation. It also logs I'm sorry, there's background noise, but it also logs the patient's pressure point alternations. So we have been through a journey of iterations for the product, and the first concept, like you see here, and then following new ideas, the patents are listed here. But the final and the greatest of all is the compliant mechanism-based technology, which is patent pending, and I'll show you more details in the next slide. So this is a patent pending technology, and I don't have the animation in this because this is a PDF version, but essentially as these trapezoid shape here, it moves and it hinges, or it touches these triangular structures, creating alternating highs and lows. So it's a sine wave that's formed, and you have high points that are pressure points and the low points that are low pressure points. And this is a bistable technology made using compliant mechanisms, and it works on the basis of strain energy. So what happens is when the patient is laying on this mattress, there is very limited, the amount of force that it takes to change positions is 1/10 of the patient weight. So imagine if a 200-pound patient is laying on it, he can be lifted with almost 10 to 20-pound force. The weight can be changed. The position can be changed. So this is the prototype that we have developed. And like you see here, there is a person standing on this prototype, and additional weights are put on the prototype. And you can see here, these are the pressure profile that's on a computer screen, and you can see the red dots alternate. So this is one end of one position, and when it goes to the other stable state, which is moving these trapezoids to the left, these are the other set of pressure points. So we are using AI to determine what pitch and amplitude would work best. Without spending too much time on this, essentially what we are trying to see is what pitch and amplitude will get us no dead zones, because we want to minimize the dead zones. So there are existing products, but none of them get a good recommendation because of their inefficiency to prevent bed sores. There are certain very high-end products which cost more than $50,000, but are not practical to use. So you can see here our mattress is cheaper, no air pumps, no air valves, and reimbursed, and minimal power to change states. Next slide, please. I'll just use another quick, let me just quickly use one more minute. So regulatory classification, this is a class 2 product. It's 510K exempt, and the clinical trial is not required. This is a big market, and our selling price is $1,000. Cost price is $400. The total market size is $2.32 billion.